Welcome to the Q&A session 12 from the playlist of System of Particles and Rotational Motion. The topic is the magnitude and direction of the net torque. And based on this topic, I have one question for this session which is written here on this board. This figure was also provided along with this question. So the question here is, a figure shows a wheel of radius 20 centimeter acted upon by forces at different points. So these are the 4 points at which forces of different magnitudes are acting on this wheel of radius 20 centimeter. So the net torque produced about the point O. O is this point. O is the center of this wheel. So the net torque produced about O is. So 4 options hai. We have to find the correct one. So in this question we will be using the subjective equation of torque, which is equal to the magnitude of the applied force multiplied by the shortest distance between the line of action of force. The shortest distance between the line of action of force and the point about which we have to find the torque. So this is the subjective equation of the torque, that is torque is equal to applied force, the magnitude of the applied force multiplied by the shortest distance between the line of action of force and the point about which we have to find the torque. So by using this definition, we can find the magnitude and the direction of net torque which is acting on this wheel due to the application of these forces at different points. So let us first of all consider the point A. Now the line of action of force is this one. This is the line of action of force. Okay, this is the line of action of force, and the shortest distance between the line of action of force and the point about which we have to find the torque, we have to find the torque about O. So the shortest distance will be the perpendicular distance. So the perpendicular distance is 20 centimeter, which is the radius of this wheel. So the torque, I am writing here the net torque. So the net torque will be equal to the torque due to the force which is applied at this point A, the force which is applied at this point B, the force which is applied at the point C, and the force which is applied at the point D. So we have to find the magnitude of the torque in each case, and then we will be finding the direction of the torque due to each and every force, and thereafter we will be able to find the net torque. So the net torque, or we can say the torque, in fact, the torque due to the force at the point A, this will be equal to 4 Newton multiplied by 20 centimeter. So 4 into 20 centimeter, that is in meter, this will be equal to 20 by 100, and the direction of this torque will be anti-clockwise, and this is Newton meter, and this is anti-clockwise. Simply now the torque due to the force at B, this will be equal to the magnitude of force, which is 8, multiplied by the shortest distance between the between the line of action of force and the point about which we have to find the torque. So this is the shortest distance, which will be the perpendicular distance. So this is angle 30. So this perpendicular upon hypotenuse, this is 20 centimeter. The radius of the wheel is 20. So perpendicular upon hypotenuse will be equal to sine 30. And perpendicular is what? Let us say this is the point, say P. So OP upon OB will be equal to sine 30, which is equal to 1 by 2. So OP will be equal to OB by 2. OB by 2. So OB is equal to 20 divided by 2, which is equal to 10 centimeter. So the torque due to the force of 8 Newton at the point B will be equal to 8 into 10 divided by 100 Newton meter, and this will be clockwise. Now the torque due to the force at the point C. Now this force, the line of action of this force is passing to this point O. So the perpendicular distance, or you can say the shortest distance, will be equal to 0. So the torque due to the force at the point C will be equal to 0. Now we have to simply find the torque due to the force which is acting at the point D. So the torque due to the force which is acting at the point D will be equal to the magnitude of the force, which is equal to 9, into the perpendicular distance between the line of action of force and the point about which we have to find the torque. So this is the line of action of force, and the perpendicular distance, or you can say the shortest distance between the line of action of force and the point O, is equal to 20 centimeter. So this is equal to 20 by 100 Newton meter. So this is equal to 1.8 Newton meter. So the torque at the point D will be equal to 1.8 Newton meter, and this will be again clockwise. Sorry, this will be clockwise. So now we have to simply find the net torque. So the net torque will be equal to the torque due to the force at the point A is in the anti-clockwise direction, but the torque due to the force at the point B and D are clockwise. So the net torque will be equal to, this is equal to how much? 0.8, this value, that is the torque due to the force of 8 Newton at the point B. So because of this force, the torque which is produced is equal to 0.8 Newton meter clockwise, plus the torque due to the force at the point D, this is 1.8 Newton meter, and the torque due to the force at the point A, this is producing a torque which is equal to 4 by 5 is equal to 0.8 Newton meter. Now here I have used a minus sign because here if I am taking the torque in the clockwise direction as positive, then the torque in the anti-clockwise direction will be negative. So this and this will get cancelled out. So finally I am getting 1.8 Newton meter clockwise. So the correct option here is B. So thank you very much for joining this session. In the next session we will be coming up with a different type of a question, and the chapter will remain the same, that is system of particles and rotational motion. So till then, have a nice day. Bye.